Imagine a time machine, a device capable of traversing the vast corridors of time, not of gears and lights, the kind you might find in a science fiction novel, but of gold mirrors and precision instruments built with cutting-edge technology. This is the James Webb Space Telescope, humanity's most ambitious attempt to look back in time, floating 1 million miles from Earth, far beyond the reach of human repair, peering into the universe's deepest past, seeking to unravel the mysteries of cosmic dawn. Its mission, to look back in time, to witness the universe as it once was, by capturing light that began its journey billions of years ago, light that has traveled across unimaginable distances. When Webb observes distant galaxies, those faint pinpricks of light in the inky blackness, it sees them as they were eons ago, not as they are now, offering a glimpse into their infancy. Unlike Hubble, which shows us the universe in visible light, the kind our eyes can see, Webb reveals the hidden cosmos in infrared, a spectrum invisible to the naked eye, peering through cosmic dust to the universe's first moments, when stars and galaxies were just beginning to form. Its 18 gold-coated mirrors, each meticulously crafted and aligned, form a giant, ultra-sensitive eye, a window into the deepest reaches of space and time. So precise it could spot the heat of a bumblebee on the moon, a testament to its incredible sensitivity. We built Webb to answer the biggest questions, the questions that have haunted humanity for centuries. How did galaxies form? Where do stars come from? What were the conditions like in the early universe? Are we alone? Is there life beyond Earth? Scientists pointed it at the void, into the seemingly empty regions of space, searching for the chemical fingerprints of the first stars, the building blocks of everything we see today. Hydrogen, helium, the universe's original elements, forged in the Big Bang. But the universe had a surprise in store, something unexpected lurking in the darkness. As data streamed in, a torrent of information from the farthest reaches of the cosmos, the team expected to find the faint glow of the past, the dim light of the universe's infancy. Instead, they stumbled upon a signal, an anomaly that defied explanation. That would challenge everything we thought we knew, forcing us to reconsider our place in the grand cosmic scheme. The abyss stared back, revealing the limitations of our current understanding. Revealing a secret encoded in ancient light, a message from the dawn of time. The team, huddled over their screens, poring over the data, realized they were on the verge of a discovery, a breakthrough that could change everything, that could rewrite our understanding of the cosmos, forcing us to rethink everything we thought we knew about the universe. The universe was about to deliver a message that would resonate across the ages, one that would shake the foundations of science, challenging our most fundamental assumptions. Sometimes when you look for answers, when you embark on a journey of scientific inquiry, you find questions you never imagined, mysteries that deepen the enigma of the cosmos. And so began the story of a discovery, a tale of scientific adventure and cosmic revelation that would change our place in the universe forever, shifting our perspective on everything we thought we knew. Webb's target was a seemingly unremarkable patch of darkness, a void nestled between distant galaxies. It was a place where light struggled to reach, a region that appeared utterly devoid of celestial activity, a place other telescopes, even the mighty Hubble, saw as empty, a cosmic wasteland offering nothing of interest. Undeterred, astronomers directed Webb to stare intently for hours, a prolonged gaze into the abyss. The goal was to collect every faint photon, every whisper of light emanating from the universe's infancy, a period known as the cosmic dawn. The data returned as a torrent of numbers and spectral lines, a complex tapestry of information woven from the faintest light. It was all waiting to be decoded, a puzzle box of cosmic secrets. At first glance, everything seemed to match expectations, confirming existing models of the early universe. There was primordial gas, the raw material from which stars and galaxies are born, and faint hints of early galaxies, the seeds of cosmic structures yet to come. But then, a junior astronomer, poring over the data with meticulous care, noticed a tiny, persistent spike. It was a signal so faint, so subtle, that it could have easily been dismissed as random noise, an insignificant fluctuation. But defying all odds, it wouldn't go away, stubbornly refusing to disappear. The team ran every diagnostic imaginable, meticulously checked for glitches in the instruments, ruled out any possible interference from earthly sources, and compared the signal to every known astronomical phenomenon. It wasn't a quasar, blazing with energy from a supermassive black hole or a distant background galaxy. The chemical fingerprint, revealed through spectral analysis, was utterly unique, unlike anything they had ever seen. The source appeared to be a rogue planet, a world without a star, drifting alone in the cold, dark expanse of interstellar space. That discovery alone was remarkable, challenging our understanding of planetary formation and the prevalence of rogue worlds. But the signal's nature, the information encoded within its spectral lines, was even more astonishing, bordering on unbelievable. An analyst, running advanced algorithms, matched the spectral lines to a complex biosignature, a chemical marker indicative of life. Specifically, a molecule on Earth produced almost exclusively by living organisms, a byproduct of biological processes. The signal wasn't just random chemistry, it wasn't just some complex molecule formed by chance. It was a potential calling card from life itself, a tantalizing hint of biology operating on a world far, far away. And it was found in a place where life shouldn't exist, on a rogue planet adrift in the hostile emptiness of interstellar space. The control room fell silent, the hum of computers fading into the background. A heavy silence descended as the implication of the discovery slowly settled in, a realization that rippled through the room. They had found something that defied every expectation, something that challenged the very foundations of our understanding of life in the universe. The universe had just whispered its first, tantalizing hint of life beyond the stars, a cosmic secret revealed in the most unexpected of places. The James Webb Space Telescope, with its unprecedented capabilities, peered into the atmospheres of distant worlds, seeking the telltale signs of life. And it found something truly extraordinary. Webb had detected dimethyl sulfide, DMS, in the atmosphere of a rogue planet, a world known as Ophion 1, a planet adrift in the vast cosmic ocean, untethered to any star. On Earth, DMS is a byproduct of life, a key indicator of biological activity. It's primarily produced by oceanic phytoplankton, those microscopic marine organisms that form the base of the ocean's food web. The scent of the sea? That's DMS, wafting through the air, a subtle but unmistakable sign of life teeming beneath the waves. It's a sign of a living planet, a planet where biological processes are actively shaping the atmosphere. But this planet, Ophion 1, is nothing like Earth. It presents a stark contrast to our vibrant, life-filled world. It has no star, drifts through freezing space, a lonely wanderer in the interstellar void, and by all accounts it should be a dead frozen rock, a lifeless chunk of ice and stone. Yet Webb found a strong atmospheric signature of DMS, an unmistakable biosignature where none should exist. And it wasn't just a trace amount, it was far more than a trace, suggesting a massive active source, something actively producing DMS on a large scale. The scientific community was stunned, grappling with the implications of this extraordinary discovery. Finding life on a planet orbiting a star, within the familiar warmth of a sun, would be monumental. But finding it on a starless world, a world shrouded in perpetual darkness, was unthinkable. It shattered our models of habitability, forcing us to reconsider everything we thought we knew about where life could exist. We've always searched for life in the Goldilocks zone, that sweet spot around a star, where a star's warmth allows liquid water to exist on a planet's surface, the key ingredient for life as we know it. Ophion 1 has no sun, no warmth, no Goldilocks zone. It exists far beyond the reach of any star's life-giving rays. The presence of DMS implies biology, a biological process actively producing this compound, which implies liquid water and energy, the fundamental requirements for life to thrive. But where could energy come from on a frozen, starless world? What could possibly power a biosphere in such an environment? The discovery wasn't just surprising, it was deeply perplexing. It seemed to break the rules of the universe, defying our understanding of how life can arise and persist. Ophion 1's DMS is a profound anomaly, a cosmic riddle demanding a new explanation, a new framework for understanding the possibilities of life in the universe. This discovery forces us to rethink where life can exist. For decades, we searched for life by following water and starlight, focusing on planets orbiting stars. It made sense. Earth's life depends on the sun. But Ophion 1 defies that logic, suggesting life doesn't need a star at all. The universe might have a plan B for biology, thriving in the cold and dark. This means habitable worlds could be far more common than we imagined. Rogue planets, once dismissed as dead, could number in the trillions. If even a fraction harbor life, the galaxy could be teeming with living worlds. Life might not be rare or confined to cozy solar systems. It could be a persistent force, thriving in the most extreme environments. The universe just got a lot less lonely, and a lot stranger. This discovery challenges our Earth-centric view of life. It hints at life evolving in perpetual darkness, powered by unknown forces. We may be just one example in a vast library of cosmic possibilities. The rules of life are broader than we ever dreamed. How could life exist on a frozen, sunless world like Ophion 1? The leading theory, internal heat, not starlight, powers this planet. A geologically active core, heated by radioactive decay, could keep a subsurface ocean liquid beneath miles of ice. In this dark ocean, life would rely on chemosynthesis, using chemical energy from hydrothermal vents, not sunlight. Earth's deep-sea vents support entire ecosystems this way. The DMS Webb detected could be a waste product from these chemosynthetic organisms, seeping through cracks in the ice. Ophion, the 1st of May, be alive on the inside, its only sign of faint chemical breath reaching our telescope. This discovery reshapes our view of life in the cosmos. The Fermi paradox asks, if the universe is vast, why haven't we found life? The answer may be that life is common but hidden, thriving in subsurface oceans on icy worlds. Life isn't a delicate flower, it's a tenacious weed, sprouting in the cracks of the cosmic pavement. The galaxy could be filled with microbial life, invisible to our old methods. Maybe intelligence is rare, or maybe we've just been looking in the wrong places. Our existence is less of a fluke, more a predictable outcome in a universe full of possibilities. We are part of a vast, unseen web of cosmic biology. We are not alone, we are one branch on a cosmic tree of life. The Ophion 1 discovery opens 1,000 new questions. Can we find similar biosignatures on other rogue planets? Is Ophion 1 unique or just the first of many? What is this life like? Could intelligence arise in such darkness? If life thrives in extreme environments, might we find it closer to home, on Europa or Enceladus? The discovery challenges us to explore responsibly as potential guardians of a cosmic ecosystem. It asks us to reflect on our place in the universe and inspires us to keep searching. The universe has spoken. Now we must listen.